the mathematics that can explain the patterns in nature. If we observe nature carefully, we will find that there are patterns everywhere, from the expansion of our universe to the symmetry of a human's face. They all show some pattern. There are countless patterns existing in our reality, and we can say that every object, no matter how big or small it is, directly or indirectly exhibits some pattern. You might have observed patterns like rain droplets, symmetricity of nature, patterns in a great architecture sites, etc. But do you know that these exist much more complex patterns that are not visible to naked eyes? But if we observe, we might discover some of the most beautiful patterns. With time being great mathematicians and philosophers like Aristotle, Galileo, Newton, Kepler studied these patterns to implement them into our daily lives. One of these mathematicians was Fibonacci, who gave his famous Fibonacci series, which helped in understanding of these patterns in a much easier way. Fibonacci series was able to explain most of the patterns that emerge out as a spiral. The expansion of our universe and the spiral shape of galaxies, the symmetry of flowers, the symmetricity of our face, patterns in hurricanes, etc. It always remained impossible to understand how these all patterns originated. The answer to which was given by Fibonacci number. Now, to understand how the Fibonacci series explains these patterns, we need to understand what it is first. Fibonacci series is an arrangement of numbers where each preceding number is the sum of its previous two numbers. Hence, starting from 1, the sequence becomes 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89 and so on. Research shows that Fibonacci numbers first appeared in Indian mathematics around 450 to 200 BC. However, it came to be known as a sequence when Fibonacci introduced it to the world around 1200 AD. To analyze patterns, we will first make a square with a side equal to Fibonacci numbers. Hence, we get the first square of side 1 unit, second of side 1 unit, third of side 2 unit, fourth of side 3 unit and so on. Now we put the first and second square adjacent to each other. It becomes a rectangle with a length of 2 units and the breadth of 1 unit. This 2 unit length can be used to make a square of side 2 units, and further, when all these squares are placed together, another square can be made of side 3 units. This process can be repeated indefinitely. Now, starting from the first square, we can make a quarter circle as the angle it subtends at the center is 90 degrees. And when we continue this circle for each square, we will observe that it gives us a spiral. Through this way, mathematicians were able to explain all the spiral patterns, like how they appeared and how they will diverge, and further derive their application into the real world. It helped us to understand how huge spiral patterns originated. Fibonacci also let us determine one of the most complex mathematical problems in the world, the golden ratio. And with the help of Fibonacci series and golden ratio, mathematicians were able to understand the pattern efficiently and hence apply it in our daily life. Along with this, Fibonacci numbers gave us a tool to depict many other patterns, like the petals in flower, which always appear in Fibonacci numbers. The orientation of leaves in some plants, every second, third, fifth, eighth, etc., leaves tend to orient themselves in the same direction. This property was first noted by Kepler. The symmetricity of Mona Lisa painting. Now we talk about the applications of Fibonacci number. In today's world, Fibonacci sequence is used in many fields. For example, mathematicians use it for technical analysis as it starts from a small number and can lead its way to a huge number in just a few steps. Understanding of the stock market is made easier using Fibonacci numbers. Great architectural design use patterns which can only be explained using Fibonacci